Hi guys, welcome to lesson 9.4, factoring to solve quadratic functions. Our objective for the day is that I can solve quadratic functions by factoring. See, told you it was coming back in this chapter. Alright, so problem number 1, using the zero product property. So the zero product property says that if A times B, two things multiplied together, is equal to 0, then either A or B is going to be equal to 0. And we can use this to take our terms for our factors, our binomials, and come up with solutions for each of these binomials. So we're going to start off, what we do is we write x plus 1 is equal to 0 and x minus 5 equals 0. So we take each of our two binomials, set them equal to 0, and now we just need to solve for the variable, subtract 1, and we're going to add 5. So our two solutions for this equation is going to be x equals -1 and x equals 5. Those are 2 points where we're going to get a y value of 0 when we plug them into our equation. So we're going to do the same thing for letter B. We're going to take 2x plus 3, set it equal to 0, and x minus 4, set equal to 0. Subtract 3 from both sides of the equation, then divide by 2. X equals -3/2. And our other equation, x minus 4, add 4 to both sides, and x is equal to 4. All right, looking at letter C, we have 2y plus 1 times y plus 4, so we're going to set each of those equal to 0. Subtract 1 from both sides, and then divide by 2. So y is equal to -1/2. Our second equation, we're going to subtract 14 from both sides, and y is equal to -14. Letter D, 7n minus 2 equals 0, and 5n minus 4 equals 0. We're going to add 2 to both sides of the equation. 7n equals 2, divide by 7, and n equals 2/7. All right. Our second equation, 5n minus 4, we're going to add 4 to both sides, and then we're left with 5n equals 4, divide by 5, n equals 4/5. For these kind of equations, guys, there is no need to convert those fractions into decimals, just leave them as the fractions. Letter E, we've got 2x plus 3 equals 0, and x minus 1 equals 0. Subtract 3 from both sides of the equation, and then divide by 2. And we get x equals -3/2. Our second solution, we're going to add 1 to both sides, and x equals 1. Moving on to problem 2. Here we're going to have to do the factoring ourselves before we can solve these problems. So we're looking for two factors that are going to multiply to -14 and add to -5. So we're going to have a 7 and a 2. The 7 is going to be negative, the 2 is positive. So now we can solve each of those two factors for 0. So m minus 7 equals 0, and m plus 2 equals 0. Add 7 to both sides, m equals 7. And subtract 2 from both sides, m equals -2. Those are our two solutions. All right, so letter B, we're looking for products of -20 that are going to add up to a +1. So we're going to have 5 and 4, +5, -4. So we set each term equal to 0, subtract 5 from both sides, and p is equal to -5. and p equals positive 4. Okay, letter C, we're going to have to do the box method to try to figure out what we've got. So we're looking for factors of 36 that are going to add up to negative 15. All right, so we've got negative 2 and negative 18. Those are going to add up to negative 20, not quite what we want. How about negative 3, negative 12? Those multiply to 36. They add up to negative 15. So we have negative 3a and negative 12a. Make sure you pull those negative signs out right away. And in our first column, we're going to have 2a as a common factor. In our second column, we're going to have a 3 as a common factor. First row is just an a and a negative 6. So our two terms are going to be 2a minus 3 and a minus 6. Set them both equal to 0. All right, add 3 to both sides and then divide by 2. And we're left with a is equal to 3/2. Add 6 to both sides, and a is equal to positive 6. Moving on, in problem 3, we're going to have to write these in standard form first. So that means we want them to be in the form ax squared plus bx plus c equals 0. So we're going to add 49 to both sides of the equation. So we're going to get x squared plus 14x plus 49 equals 0. And does that look like one of those special cases to you?
Square and a square.
And the middle term is 2 times each of the factors. So we have x plus 7 times x plus 7. You could also rewrite that as x plus 7 squared. So now we set that equal to 0. X plus 7 equals 0. Subtract 7 from both sides, and x equals negative 7. So there is only one solution for this quadratic equation. All right. Letter B, we've got, what are the solutions? We need to add 4 to both sides. So we have 3x squared plus 13x plus 4. And we are looking for factors of 12 that are going to add up to 13, and that's pretty easy. It's just going to be a 12x and an x. So our first column, we've got 3x as a common factor. Don't forget, it's 3x squared in the box. And we've got a positive 1 as a common factor in the second column. First row is just an x. Second row is going to be a 4. So we have 3x plus 1 times the quantity x plus 4. Set it equal to 0. 3x plus 1 equals 0. X plus 4 equals 0. So we've got x is equal to negative 4. Subtract 1 from both sides, and then divide by 3. So our other factor, or our other solution, is going to be negative 1/3. Our last question, why do quadratic equations in the form x squared plus 2ax plus a squared equals 0, or x squared minus 2ax plus a squared equals 0 have only one real number solution? And that's because they are perfect square trinomials. There is only going to be one factor that you're gonna, or one binomial that you're gonna have there, because they're both gonna be the same. They are perfect squares. So when we have a perfect square trinomial, one solution. All right, lastly, we've got a couple word problems for us today. So we're going to start off with, we've got a frame for a rectangular photo, and we want to know what the dimensions are going to be given a certain area, which is 315 cubic inches. So we know that our picture frame is 17 by 11, so we're going to use that as our starting point. So our first factor is going to be 2x plus 17. Okay, we've got the width is 17 plus x on the two borders, so it's 2x's. All right. Our second one is going to be 2x plus 11. We've got that same width of the border all the way around, and then we've got an 11-inch picture in the middle. And that equals 315. All right, next up, we need to distribute this. So, use FOIL. We've got 4x squared plus 22x plus 34x plus 187 is equal to 315. So we need to get this in standard form, so we're going to subtract that 315, bring it to the same side of the equal sign. And we've got 4x squared plus 56x. We'll just combine like terms in one step. Minus 128 equals 0. Now that looks like we can take out a common factor there. We can pull out a common factor of 4. And we're left with x squared plus 14x minus 32. It's all still equal to 0. Now we can factor. We're looking for factors of negative 32 that add up to 14. And we've got positive 16 and negative 2. So now we're going to set each of those two terms equal to 0. X plus 16 equals 0, and x minus 2 equals 0. So subtract 16 from both sides. X equals negative 16, and x equals 2. But our question was asking us, what is the outer dimensions of our frame? Now we can ignore the x equals negative 16 solution because we can't have a dimension that's negative 16 inches. So we're going to use that x equals 2. So the border is going to be 2 inches all the way around. So we can plug that into our original two factors to find out what our length and our width are. So 2 times 2 plus 17 is going to give us a total of 21. And 2 times 2 plus 11 is going to give us 15. So our frame is going to be 21 inches wide and 15 inches tall. And Miss Zirzo put it in a nice little box for us.
It's in a frame.
Okay.
All right.
All right, moving on. Letter B, if the total area of the frame in the photo were 391 inches squared, what would the outer dimensions of the frame be? Well, we're just going to jump right into using our factored form, or our foiled form, which is 4x squared plus 56x minus 128, and that's equal to 0, or equal to 391. Subtract 391 from both sides, and we've got 4x squared plus 56x minus 204 is equal to 0. We can factor out 4 again. So we've got an x squared plus 14x minus 51. And when we go to factor that, we're going to find that we have x minus 3 and x plus 17. And once again, we take each of those terms and set them equal to 0. X plus 17 equals 0. X minus 3 equals 0. So we've got x equals negative 17 and x equals positive 3. So we can ignore the negative answer because we can't have a negative dimension for our frame. So we're going to have 3 for our dimensions. We've got 2 times 3 plus 17, which gives us 23 inches. And we've got two times 3 plus 17, or plus 11, which gives us 17. 23 inches by 17 inches. Our last example, we have Jason with the has a pool that has a patio with uniform width around it. The pool is 22 feet by 12 feet, and the patio is 504 square feet. So we set up, we've got 2x plus 22 and 2x plus 12 as our two binomials here, and that equals 504. So we start off by foiling again. 4x squared plus 24x plus 44x plus 264 is equal to 504. Subtract 504 from both sides. And we'll combine like terms. We got 4x squared plus 68x minus 240 equals 0. And now we can factor out a common factor of 4 from everything. So we have x squared plus 17x minus 60 equals 0. And our two factors for that, we've got x plus 20 and x minus 3. Set each term equal to 0. And our two solutions are x equals negative 20 and x equals 3. And the only one that makes sense is that positive 3, which answers our question. Let's just remember we need to put in our units. Our patio is 3 feet wide. Do not forget your units. All right. Thank you, and we'll see you in class.